See, basically, what what are these curve? Time versus current. I am plotting a curve like this. So, if the current is, let's say the current is 2 times. That time my relay will be operating at, let's say, 3 seconds. Let's say it operates at 3 seconds. Now, if my current increases to, let's say, 7 times, that time my relay will reduce. The operating time of the relay will reduce to, let's say, 1 second. Now let the current seen by the relay goes to 10 times. That time my relay will operate at zero point 0.8 or 800 milliseconds. Okay. Now I have my breaker. Okay. My breaker is having a current transformer. Now that current transformer is connected to my relay 51. That relay 51 will see a fault current and then it will give a trip signal to this breaker. Similarly, I'm having one more uh, outgoing feeder also. I have a breaker. That breaker also has a relay. So now the characteristics of relay, this relay is basically you have to select whether I will go for IEC or IEEE. In IEC, whether I'll go for standard inverse curve, very inverse curve, or extremely inverse curve. Okay. Now, during coordination, what will happen? Okay, I have to add my other curve also. I have to add here. So the curve characteristic, these two curve characteristics, I can change. Now, one of you asked, now this curve has a equation. What is that equation? The equation of the curve is nothing but the time t is numerator divided by denominator. Okay, basically it is of this form. This is one. What is numerator? It is product of two number x and what is denominator? That is nothing but something a by b raised to the power of something. Now what is this x? X is nothing but the time multiplier setting k. What is y? Y is nothing but a constant. Okay, constant. I will write it in red. And what is this terminology here? A. This is nothing but current I. Okay. And what is this current? It is nothing but the pickup. This current is nothing but the I set. Okay, the set value. And what is this one? This is alpha. It is again a constant. Okay. Now here, this alpha and beta are dependent on the type of curve. Now one of you asked, what is the significance of this K? See, this curve, I can see relay coordination is all about two things. It is basically what is relay coordination? Relay coordination is all about playing with the curve. Playing with the curves. When I say playing with the curve, you should be able to move the curve up and down. Number one. Number two, you should be able to move the curve left and right. Okay. Okay, everybody?
Yes, sir.
Yeah. To move the curve up and down, what you will do? Mr. Naveen Kumar.
Yes, sir.
What will I do to move the curve up and down?
We can change the time setting.
Time setting, absolutely correct. So here, this time multiplier setting K. If I vary this, I can move this curve. From here, I can change this curve. See, I can bring the curve here, or I can move the curve further here, or I can like this. I can move the curve up and down by changing this K. Okay, remember this K, the equation. You are exactly correct. Okay, Mr. Pinaki, you are clear now?
Yes, sir, I'm clear, sir. So to move it up and down, I'll use the time multiplier K. If I want to move the curve left or right, then I have to use.
You make that and you tell that answer. Can you do a guess? How do I move my curve left and right? Can you please tell?
I should move that I set because I have to move the current I left and right.
I
So
I and I set you don't have control over I. You can change I set, okay? I set is nothing
okay,
but your pickup current. So if I change the I set, this fellow will change. This point is all about I set. If I change this point, I can shift this point here. So it can come here. When it comes here, the curve will start here. Okay.
okay. So the I set is the starting point of the curve is the I set. So
Yes, it is the pickup current is this starting curve, starting point.
okay, sir.
So I can play with the curve left and right by changing this I set. Okay. So basically, if I want to move the curve left and right, I have to change. I can change this I set. So, so I can move here, and for that, in this equation, okay, I have to change the I set. Okay. Now,
Sir,
yes,
sir, one
sir.
doubt, sir.
Yes, sir.
In this equation, this if you are doing it manually, this I how we can find, sir? This means relay input or CT secondary current.
So this current that I will tell you now here.
Okay.
See, when I'm doing the relay coordination, um, this I is nothing but it is a number of points. Okay. Suppose the fault current here is, let us say this is a 1 MVA. So 1 MVA is nothing but, let's say, the 1400 amps. Okay, the low voltage current. Now, if there is a fault current, let's say the fault current is 14K. Okay. Now I set maybe at, let's say, 1400 amps, and I is, let's say, 1000. It is 14K. So 14Ka means I will be here. Okay. But then I'm getting only one point, right? But I want, in order to plot the curve, I need all the currents, right? Not just one current. So how do I do that? I will teach you in the next class. I'm going to, that is the reason I have taken the help of Excel. I will plot all the currents, okay? In the next class, I will tell you. 1400 amps, 1500 amps, 1400 amps, up to 2500 amps, 25,000 amps. Up to here, I will plot all the currents and I will get the time. And then I will convert it to a chart. So your answer to your question only partially I've given now, but in detail I will be explaining in the next class. Okay. Anybody else? Any doubt on this particular thing?
No, sir.
Loganathan sir, any doubt?
So this alpha, beta, those are constant values which we derive from based on the curve that we select, right? That comes
This
from the relay manufacturer.
alpha, beta basically is the when they did the research long time back, when it was IDMT relay, they determined that these are the characteristic curves of those relays. Okay. And then the relay manufacturers have been using those curves and now we are using. So this is actually determined by the relay manufacturer based on the characteristic which is required for the relay. So that, I know my damage curve. These curves were developed based on the damage curves. Okay. Okay, Pinaki ji.
Yes, sir.
So this alpha and beta, see, it is very simple. You take any curve, I will tell you how alpha beta came particularly. I tell you. See, I got this curve. Let's say I will take you back 100 years. Okay, and we developed this curve. Okay, we have an electromechanical relay. We did the testing of the relay, and after doing the testing of the relay, I got this curve. Okay. First, I will make a relay, electromechanical relay. After making the relay, I will do the testing, and when I do the testing, I will plot this curve. Okay. So up to this, it is clear. First, I will make a relay. After I make a relay, I will do the testing. After testing, I will plot the curve. I got the curve. Okay. Now, 100 years is over. I have the curve with me. I no longer have electromechanical relay. I have electronic relay. So how do I make my electronic relays behave like electromechanical? I have to basically create this curve. So what do I do? You know this curve fitting, right? So using curve fitting, I will convert this curve to equation.
Right.
Okay. So when I convert the curve to equation, I get this equation. And that time I do all this testing, and finally I derive that I come with some 100 equation, and finally for each equation I come across some constants, and finally I realize that okay, this is the best fit for this curve, this is the best fit, and then I standardize. I have around 100 curves. Finally I decide this 10 curve I will use, and for this 10 curve I will come with a neat some table like K and beta. So then they will say, okay, IEC curve 1, K is this one, beta is this one, like this it came. Okay, that is how it evolved. Clear?
Yes, sir.
Okay, any other doubts on this particular thing?
Sir, I also had the same doubt. I mean, about the alpha and beta. Does
Yes,
that
sir.
change from manufacturer to manufacturer, sir? Or
No, sir, no. See, when they standardize, if I say IEC, if I say IEC standard inverse curve, ABB also alpha and beta, this alpha and beta has to be same. Cell relay also alpha beta has to be same. GEC also has to be same. No manufacturer can change. If I say IEC, instead of IEC, see there are 10 curves, right? IEC and IEEE curve. If let's say vendor will give some other his own custom curve. He will tell ABB curve, some AB something. Then alpha and beta he can change. But if I call the curve as a IEC standard inverse curve, I should not change the value of alpha and beta. Okay. If you want to change the value of alpha and beta, please do it, no problem. But then don't call it as a IEC, normal inverse curve or standard inverse or extreme inverse. You give your own name. Clear?
Yes, sir.
Yeah. So, anybody, any other doubt?
I missed the initial 2-3 minutes of the session.
Yeah.
Did we discuss on the exercise? I think one doubt I had on that. The
Yes, sir. Please tell
ABB
me.
catalog. In the ABB catalog, I didn't find the moment of inertia of the load. So because that may be given by the the type of the load or whatever we are using.
Yes, sir. The
So
same
I
thing.
assume some value.
Yeah. See, the same thing actually I explained in real problems when we are doing in the this one, we should not assume. But now today for your this one you can assume and calculate because this moment of inertia of the load is most important item in the starting time of the motor. So in actual cases, what you can do is, if it is a pump or a fan or a compressor, whatever it is, you have to ask the vendor. So what you can do is, in your company, you have your mechanical team or your normally mechanical guys only are doing the pump data sheet, no? So you have to tell them that please get me this data from the pump vendor. Okay. So we there, but here you can assume now for the sake of your understanding purpose. But in real scenario, please never make assumption. You tell the vendor directly, sorry, I cannot make assumption because see, your entire relay coordination will is not a child play. Okay. Uh, See, if I am doing calculation of a transfer cable sizing, okay, I will one cable size I will determine, but relay coordination is not like that. If I make one mistake, now I'm having so many feeders. If I make a wrong judgment of this particular relay, the entire thing I have to repeat. Okay, well, this one motor here will dictate the setting of this one incomer, and this one incomer will dictate the setting of some 100 outgoing feeders. So please never accept. You small motor, okay, fine. Big motors, you be very firm. You tell that you want the inertia, all those data. Okay, but if it is small motor, LV motor, whatever software is giving, you can accept that. Okay. Okay, sir. Any other doubt? Any other doubt on today's session?
No, sir. No, sir.
Okay, sir. Now able to see the screen?
Yes, sir.
Okay, so I have shared the link of the TBB, this one. Please go through that. So you can see the values of alpha and beta. Alpha changes from 0.02, it increases to 1 and 2. Beta changes from 0.14 to 80. Okay. I have explained this also. Whenever you are doing your time coordination equation, so what is the pickup value you are going to set? Choose 0.5, 0.6. How to choose the pickup value? I will tell you tomorrow. Mr. Naveen Kumar.
Yes, sir.
How do I choose the pickup value?
It's depending upon the load conditions, sir.
Okay, so tomorrow can you just some typical values you can tell me to next class, okay? Pick up value, huh? Yeah, everybody one small exercise. Please write down. Rating is whatever just now I wrote in the board, no? For that itself. For that incomer breaker. Okay, I will give you this exercise. Please, both you please see the board. I will stop the sharing. Let me rub other things. Able to see the board clearly? Everybody? Are you able to see the board?
Yes, sir.
Okay, please. Okay, this SLD. Okay, let me. This one is 1 MVA transformer, 11 kV bar 433 volts. Okay, so operated at 415 volts. Okay, operating voltage is 415, and this motor is a let's say, what is the maximum low voltage motor rating that I can have? What is the maximum low voltage rating of the motor?
160 kilowatt, sir.
How much?
160 kilowatt.
160 kilowatt. Okay. I think last time I used 190 kilowatt was also some people use. And okay, let's say this is 132 kilowatt motor. And this is okay. Now, your exercise is number 1, incomer. What is the incomer current rating? Please find out. Number 2, what is the CT you are going to select for the incomer? Please tell me. Number 3, what is the incomer pickup you are going to give? Okay, that you have to tell. Similarly, you have to do for the motor feeder also. What is the outgoing current? Okay, and what is the CT you are going to select, and what is this outgoing pickup value you are going to give. Okay, this is the exercise for you. Please do it, and after you do, I will explain this to you. Okay. In the next class, I will explain it to you.
And that current means the breaker selection, sir. Which
Pardon, sir?
ampere of breaker. The first one, the before CT ratio, CT, mentioned incomer high, right?
Incomer current rating.
That is like what breaker, which ampere breaker we should keep in that place. You are telling about that one.
No, not sir, I'm asking you the actual, what is the rated current?
Okay, sir.
Okay, what I'm not asking you the breaker current. I'm asking what is the current. Calculate the. Okay, not now. You can do it later on. But don't forget to do this exercise, because I will next class. Okay, and after that, we will go to fault current and all. Right now, I will not tell. Next class, I will teach you how to determine the fault calculation. So here, how much current is flowing actually? That you have to determine here, okay? Here, how much current is flowing? That you have to determine, number 1. Number 2, see, there is a CT here, right? What is that CT rating? That you please write down. Number 3, what should be the pickup current of this relay and this relay? That you
So how many motors shall we consider of 132 kilowatt on the bus then in that case?
Sir, here I have told you it is 1 MVA. Okay, this one is 1
Okay,
MVA.
1 MVA.
You assume that in 1 MVA it is loaded up to 90%. Okay, you assume it is loaded up to 90%. But though it is loaded 90%, each of you please come out with your pickup. We will discuss it. Okay.
Okay, sir.
Okay. So this exercise, you please do it in the.
Pick
Yes,
up
sir.
which relay we have to follow, sir? Pick up current that what you have shown or ABB that relay.
Sir, relay for the time being, how does it matter? I am asking you the pickup current. I am
Okay,
asking
okay.
you
Based
calculate
on
the
load
pickup.
current.
Pardon?
Okay. Based on the load current, we have to set the we have to tell pickup
Sir,
current. Okay.
based on the outgoing current and also based on the incoming current, I am telling you, please decide the pickup.
Okay.
Okay. So I will also take a snapshot of this and post in that WhatsApp group. You please do it without fail, and please complete that other exercise also. So if you do that exercise, see, I know yesterday and today there was no much time, but please complete this by the next class, okay? So that we do this, then only we will understand. Otherwise, you will not understand. Okay, you will not understand means there is no use. No?
Sir, we can further this consider we can consider DOL starting, right? For this motor.
For which one?
That motor.
What for pickup? I am telling you, sir. I gave you the exercise. Select a CT, select a pickup, select a current rating. What your starter has to do with that pickup? Tell me.
But that motor starting, it should be above the motor starting, na sir.
How? See, I'm telling pickup current and pickup current. I will see. Let me clear your doubt. See, this is my relay curve. Okay. Time versus current. Now this is my motor curve, right? Now you see here, I am talking about this point, this one, okay?
Okay, sir. Noted.
So now what you are telling DOL starter, star delta, so basically it is this one. If I change the type of starter, basically these things are changing, but this one will not change. Irrespective of the type of starter, okay? So I'm talking about pickup. So for pickup, you need not worry about all those things, okay? Anybody else, any other doubt? Anybody, any other doubt? Gauravji?
Sir, I asked yesterday also if you can give us some write-up, we can revise it because we don't have any reference.
Sir, I am regularly, number one, I am sharing you the video. Number two, for further reading, I am giving you some links. The PPT I will surely give you. The entire, whatever I am teaching, the PPT 100% I will give you. But I don't want to give now because that is my strategy.
Okay.
Okay, I want you to, what I want you to read, that specifically I am giving you. PPT I will share for sure after this one. Okay.
Okay, sir.
And Mr. Krishna Kumar, no doubts. Okay, Mr. Inamul, any doubt? Loknathan sir, any doubt?
No, sir. Clear, sir.
Okay, Pinaki ji, any doubt?
No, sir.
Okay, Naveen Kumar, any doubt?
No, sir.
Okay, thank you everybody. Enjoy your weekend, enjoy your Sunday. Okay.